Good morning and welcome to the Investment Recovery Association webinar, Demolition and Environmental Fundamentals 101. I'm Jane Mail, Executive Director of the Investment Recovery Association, and we will be facilitating today's webinar. I want to share a few housekeeping notes before we get started. We have all attendees on mute, so if you have any questions, please type them in the chat box on your screen and send. If time allows, we will answer at the conclusion of the session. The presentation is in the handout section of your GoToWebinar screen and may be downloaded for personal use. It is not intended for outside distribution or use. If you would like verification of attendance for certification or recertification credit, please send me an email at jmale@westerneda.com and I will respond with verification. For those on the call unfamiliar with the Investment Recovery Association, we are a trade association formalized in 1978 and operate with a company membership dues structure, which allows for all of your IR staff to receive the benefits of the association. Dues begin at $4.99 annually for corporation members and $6.49 for vendors who provide services to those corporations. We have an initial $200 initiation fee. As a special offer to new corporation members, one registration to our April 2020 conference is included with your membership dues for the first year. And additional demolition topics and safety topics will be shared at this conference in April. Our presenter today is Mike Mitchum, CMIR. Mike is the Executive Account Manager for American Integrated Services. He is going on his 47th year in performing large-scale industrial decommissioning, dismantling, demolition, remediation, and investment recovery projects, both domestically and internationally, across a wide range of industries. In addition to being an approved professional safety source for the Texas Workers' Compensation Commission, he is also a certified manager of investment recovery. He is a past speaker at conferences that include the Investment Recovery Association, Utility Solid Waste Activities Group, Decommissioning Workshop, Energy Utility Environmental Conference, the National Petroleum Refiners Association, and many others. You can look forward to the following key takeaways from today's presentation: overview and elements of a demolition and environmental project, tools of the trade, challenges on demolition projects, safety communication and management, selecting a quality demolition company, investment recovery, and the bottom line. Let's get started. Mike, the floor is yours.
Thank you, Jane, and I'd like to welcome everybody. Good morning. We'd like to welcome everybody to Demolition and Environmental Fundamentals 101. This is going to be a very basic overview of demolition and environmental projects and is in no way inclusive of everything that you need to know to perform a project safely. Now, while there are nuances between the different industries that might cause some operational differences, many of the hazards and the risks and the methodologies and procedures to achieve a safe, uneventful, and economic project completion are basically the same. Now, Jane has already went over the agenda, so I'm just going to kind of breeze through this, but I will say that if you would like a more in-depth presentation of any particular subject, please let Jane or myself know, or if you don't see what you're really interested in on the agenda, let us know and we'll try to get it to you. Now, if we don't have time to answer your questions at the very end, then just send them to Jane and we'll make sure that we do get them answered in a timely manner. Now, every group within a company might call projects subject to this presentation something different. Now, here are the few of the terms used. Now, for the purposes of this presentation, we're going to refer to everything simply as D&E or just simply demolition projects. So these are the typical D&E service offerings broken down in accordance to the Project Management Institute approach. You have phase one, which is project planning. It includes environmental due diligence, such as hazardous material surveys, scope development, limits of design, development of a project planning document that provides a high-level options analysis to determine which services that you might need. It also allows for procurement for phase two services. Then you have phase two, which is project engineering. That includes development of D&E plans and specifications that include environmental investigation, hazmat surveys, remediation design, budget development, investment recovery assessments, RFP development, contractor pre-qualification and selection, It also includes procurement for phase 3 services. Then you have phase 3, which is project execution, the nuts and bolts, actually making the project happen. So it might include remediation, it might include decommissioning or hazardous material abatement. It might include demolition, site restoration, investment recovery, or all the above. So the next 2 slides show some of the elements of a D&E project. Some or all of these tasks might or might not apply to you, depending on whether or not you're an owner, an engineer, or a contractor. I'm not going to read the slide, but like Jane had mentioned, you can download a copy of this presentation on the link attached to the WebEx. So here's some more of the elements, and again, they're all in line with the PMI Institute approach. Now, one of the first things you must do before you tear something down is to decommission it. That collectively includes making the facility ready for further action by performing such things as lockouts and tagaouts, reroutes, purging and cleaning of piping, equipment, and so forth. So this particular project involved tearing down multiple air separation plants. We found ourselves tasked with removing several thousand cubic yards of perlite and vermiculite insulation. Using the principles of investment recovery, we were able to save the client over $1 million in handling, transportation, and disposal costs by finding a major soil distribution company that took all the material to mix with their soils to be used as fertilizer. So landfill avoidance is a very, very large part of investment recovery. In a previous slide, I referred to the principles of investment recovery. That philosophy is affectionately known as the 7 R's, starting from the reuse option, decreasing in value all the way down to remove. If you think outside the box, using the 7 R's as your guide, you can pretty much feel confident that you've exhausted all options to achieve maximum value. So let's look at the different types of demolition. Controlled blasting is probably the most spectacular, but only comprises a very small percentage of the work. This shows dropping a 300-foot-tall, 3,000-ton fluid catalytic cracking unit at an oil refinery in Oklahoma. Now, most of you have probably watched this, something like this on television or experienced it on one of your own projects. Well, everything appears to take place in seconds. It's precluded by weeks or even months of preparation that includes such things as decommissioning, asbestos abatement, and pre-weakening the structure. Then there's mechanical demolition, which is widely used with fewer man-hours exposed to the hazards. Now, while shears and processors like this are impressive, they sometimes just don't do the trick. So you must then go to the staple of the demolition industry, which is the cutting torch. Experienced demolition burners, some people call them demo techs, high burners, whatever you decide to call them, they're an amazing lot of individuals. They use terms like set cut, hinge cut, drop cut, fish mouth, and they can make a 3,000-ton structure come apart like an erector set. It takes years to become proficient with this trade, and good demolition burners are worth their weight in gold, and they're very difficult to find. While every member of the team has an important role, good demolition burners and highly experienced equipment operators make up most of the backbone of the demolition portion of any given project. Then there's also dismantling, taking things apart by cranes, either by unbolting, sawing, or using cutting torches. This is widely used with more man-hours exposed to the hazard. Now, while it is definitely a slower process and much more expensive, sometimes it's very necessary, especially when you're working in close proximity to operating equipment, utilities, piping, or anything else that cannot be damaged. So here are some of the tools of the trade. Yeah, I love modern demolition tools, but then again, I was always a big fan of dinosaurs as a kid, and that's exactly what these look like. Now, if you'll note, the operator in the excavator is protected by a cage around the cab. That's very important. Perception is a funny thing. Now, if you look at the grapple and the shears and the hammers and the processors, the operators make short work out of structures and foundations that weigh hundreds, if not thousands of tons. But they never lose sight of the fact that one piece of steel or one piece of concrete the size of their fist could hurt or kill them or somebody else if it hit them. That's why you give these operators a wide berth and not get too close. It looks so innocent from a distance, but could be very deadly up close if you're not careful. So here's some more tools of the trade. The skid steer, the man lift, the crane, and the 3-foot cutting torch. Now, if a contractor comes out to a job site with a 1-foot shop torch, be very aware. The 3-foot or longer torch, in addition to being an operational and engineering control, because it allows the cutter to keep his or her head out of the fumes, which could be toxic, it's also a safeguard where the cutter can stay further back away from the material they're cutting. That way, if it jumps on them or snaps or something, they don't get hit. Now, a 1-foot shop torch just doesn't allow you that extra added safety advantage. Construction versus demolition. If you can't measure it, you can't manage it. But make sure you're using an effective management tool. Now, many owners use construction metrics to pre-qualify and measure demolition contractors. That does not necessarily work because a demolition is an entirely different animal. Modern demolition crews are mostly mechanized, so there are fewer man hours, and demolition crews are much smaller. Even though you're dealing with more hazards, one recordable injury on a demolition project could blow your EMR and TRIR completely out of whack if compared to construction metrics. There are few formal classes to learn demolition, so mentoring as a way of learning is more the norm than the exception. Crane and rigging is more flexible in demolition, but with more hazard considerations. Accurate drawings are a rarity in demolition, and field calculations must be used in many cases to determine weights as well as center of gravity on lifts. There's more unknowns in demolition, both above ground and below ground. Here's some more challenges on demolition projects. Non-standard rigging. Remember, being safe doesn't always mean being pretty. Fall protection. You're taking everything down, so what are you tying off to? Uncharted asbestos, lead-based paint, and universal waste. You need to have a competent person on site at all times, able to recognize areas that might be suspect and missed during the hazardous material survey. Hot work. Know what to look for regarding the potential trap product and residues to prevent a fire and explosion. Unauthorized access to the work area. Have barricades, both hard and soft, with appropriate signage to prevent non-essential personnel from entering a regulated area. Sign-in and sign-out sheets are also recommended on some projects. Structural fatigue of walkways and ladders. Will they sustain your weight? Are they safe to tie off to? Are they safe to walk on? Will they sustain themselves and stay together during the lift, or will they fall apart as soon as you put pressure on them? In some cases, the best and safest removal method might be just to cut something and let it fall in a controlled manner. Sometimes that's a hard sell to the owner's safety department, but when it is the best way, it must be considered. Poor training and mentoring of workers. It's important that workers, even the certified ones, go through a mentoring program. You can have a certified crane operator, for example, with no demolition experience. Now, in some cases, they need to be placed with an experienced demolition operator before turning them loose on their own. Also, failure to make all workers aware of the big picture. It's much easier for everybody to exercise stop work authority in the event of a perceived safety hazard if they know what's going on around them. So even when somebody tells you that a process system is clean, you need to verify it on each and every cut, regardless if you're cutting it with a piece of equipment or cutting it with a torch. Now, you can tell this unit might not be clean. There could be trapped product in the exchangers, inside the piping between closed valves, line flanges, low-lying areas, inside manifolds, under tank bottoms, and so forth. Also, in many projects, especially your oil and gas projects, you also need to be concerned about preventing sparks from going into the sewers, because they too could also be explosive. Stray electrical. The owner can have all power to the structure locked out and tagged out. But what happens if somebody 30 years ago had ran an independent electrical line to the main unit that was off the main grid? We've all seen that happen. Always treat all electrical lines as if they were live until you verify otherwise. On fall protection, make sure what you tie onto is more than adequate. Do not cut yourself or your coworkers down. You've got a lot of folks up in that structure using cutting torches. Make sure they're communicating, and that gets back into having a proper balance, a ratio of supervision to workers. Use lifelines whenever necessary, and always have a 100% tie-off rule into effect. Watch for holes in the floor where grading has been removed. Cover up the holes in a structurally sound manner and put up hard barricades as soon as possible. And as mentioned before, never assume that catwalks and staircases and ladders will support you. Be aware of where you are at all times. Situational awareness is especially important on D&E projects. Always have an immediate escape route if something unplanned happens, regardless of what your job assignment is or regardless of what you're doing. One of my pet peeves is failure of a company to provide the opportunity of 360-degree feedback from everybody in the field. No one wants to get hurt, and no one wants to hurt anybody else. By having a redundant, perpetual 360-degree quality improvement process, you're creating an environment that promotes understanding and participation by everybody. So every project has enough brain power to prevent all accidents. You just need to have a program in place that is proactive at tapping into that brain power. Choosing the right company to do the work is a very large part of the puzzle to have your project done safely and economically. A few of the things you need to look for in a top-notch company, by all means, this list is not conclusive of everything, but some things. Needless to say, a great safety record and HSE program. And make sure you verify statistics. It's nothing more than numbers on a form, and you can go through the ISNet World or some of these other services and let them verify. Make sure you verify the statistics. Employee retention and experience. Do the employees know the HSE program, or is it just a fat book on the shelf? Quantity and type of company-owned equipment available for your project. Financial stability, bonding capacity, experience on similar projects in similar industries, experience to effectively use investment recovery to offset costs, commitment of the management to the plan and the length of time in business, ratio of supervision to workers in the field, and also a company's ability to turnkey as much of the work as possible with minimum subcontractors. Now, in addition to other benefits, this could result in significant cost savings by avoiding markups associated with multiple subs. Now, development of a site-specific technical work plan as well as a site-specific health and safety plan on every project is very necessary. If a contractor cannot explain to your satisfaction what their plan is, then chances are they probably cannot implement that plan. The plan should be in addition to their corporate safety protocols and be concise enough so it can be implemented in the field. Now, it should also not be resistant to change. As a friend of mine at OSHA once told me, burn the fat books and put something in place that the contractors in the field and the workers in the field can understand. Now, every worker should understand and sign off on that plan prior to being allowed on the project. Every worker should also have the right to stop work on the project without fear of repercussions if they perceive a safety hazard exists. No exceptions. And remember, it's all about the people. You could have a good company and a bad crew, or you could have a mediocre company and a great crew. Learn to evaluate both. Make sure the A team doesn't start the project and lesser quality personnel get sent in later. When you're evaluating a company's capabilities, take into consideration the talent and experience of the staff that is on that team prior to ruling them in or ruling them out. The great companies are always identifying the gaps in their services and bridging those gaps through strategic hires and acquisitions. Also, a mentor told me years ago, the most dangerous part of a D&E contract was signing your name to it. Now, if possible, and if it makes economic sense, keep as many tasks under one umbrella to avoid multiple contracts, if at all possible. Now, the next few slides show some of the elements of a contractor's site-specific HSE program. This list is not inclusive of everything that should be included, but rather just an example. Now you can download and read these at your leisure, and I'm just going to breeze through them. And again, this is not conclusive of everything that you might see, but it's basically bare bones, skeleton. This is the second slide. And there's the third slide. And again, you should be able to download these slides for further review. Now, this presentation would not be complete without addressing the impact that investment recovery has on the bottom line. Effective investment recovery is essential to a successful D&E project. So the different commodities listed on this slide have varying degrees of value, but have one thing in common, and that's that they can be used to offset costs. So instead of looking at your project as a D&E project, consider looking at it as a commodity trading project. For every ton of recyclable material you take down, you have a cost that's offset by a credit. So the best way to be competitive and achieve maximum value is through value engineering. Be creative to get your composite unit cost down and your composite unit value up. Learn the difference in value of the various metal and equipment, and look at the project as a sum of its components rather than scrap metal overall. So how does investment recovery impact the bottom line? Now, in developing a D&E bid, the company computes their gross bid. The gross bid is all costs associated with satisfying the scope of work, including overhead and profit. They then deduct their asset recovery credits. So look at the two examples. Now, in scenario number one, the investment recovery effort was non-existent or did not yield favorable results. The company's cost to perform the project would be $900,000. Now, in scenario number two, on the same project, the investment recovery effort yielded excellent results, allowing the company to have a positive cash flow without sacrificing safety or quality. Now, this doesn't happen every time, but it's very advisable as owners to know the value of your assets during the planning stages of the project to maximize the return during the execution stage. So think of the assets, both scrap and resellable equipment, as money, because that's what it is, and you need to spend it wisely. The more value you find and document through investment recovery, the less your out-of-pocket cost is going to be. So it pays to have an investment recovery plan in place. So in order to structure a project to maximize return on the assets and be successful, you must first recognize that value yourself and let the contractors know where to look to find that value during the bidding process. Provide enough lead time for the contractor to properly evaluate the project and prepare their estimate. So many companies, many owners want a stellar bid, but they don't want to give the contractors enough time to evaluate. What happens in many of those cases is that the contractor piles on significant dollars to cover contingencies associated with unknowns or things that they did not have a chance to evaluate. Design a well-defined scope of work with the right contracting mechanisms. Develop a schedule that complements that scope of work and allows for investment recovery activities. Now, on the schedule, make sure the contractor does not remove the most valuable assets first and then walk away from the project. Again, look at the assets as money. Be receptive to alternatives, but research the true value of those alternatives. Promote ethical and transparent behavior through example. Provide accurate documents showing weights and metallurgies if they are available. Do not provide unnecessary documents. RFPs that have hundreds and hundreds of pages of unnecessary documents causes confusion that could cause somebody to make a mistake and increases the time to prepare a bid just by having to review all those documents to get to the things that you do need. Have an accurate hazardous material survey. Make sure the bids are submitted in a manner that they can be properly evaluated, comparing apples to apples. I got another slide that will graphically show what I mean by that in just very shortly. Now, establish strong scrap handling protocol, protect against loss and theft. While this applies mostly to contractors, the owner should also be concerned if they're in a partnering or revenue sharing arrangement. Now, understand the true value of an asset by performing a cost of benefit analysis on all major items. So make sure you know what your true net return is so you can do what's best for the project. This mostly applies to contractors again, but it's good information for the owners to know. Now, in other words, don't spend 50 cents a pound salvaging something that you're only going to get 20 cents a pound for if there's a cheaper way to do it, or you can make more money by scrapping that particular item. There are two basic categories that must be taken into consideration when evaluating and managing costs. You have tasks where there are scrap and salvage credits to help offset the unit costs, such as taking down metallic items or anything that's recyclable. And then you have tasks where there are no scrap and salvage credits to offset the unit costs, such as trash disposal, remediation, and asbestos abatement. So here's a simplistic way of explaining that. If a contractor has a composite unit cost of $400 per ton, and their composite unit credit is $200 per ton, you can expect to be charged $200 per ton to have your work completed. Now, if that contractor sells a generator for what equates to $1,200 per ton, they would have an excess of $800 per ton that could be applied against non-revenue producing tasks. On any given day on the market, in the USA, plate and structural steel scrap might be selling for $200 per ton. Copper might be selling for $5,000 a ton, and nickel might be selling for $10,000 a ton. Meanwhile, your composite cost might hover at $400. All excess revenue could be applied against the non-revenue producing tasks. The scrap market plays a very large part in the economics of a project. So these charts show the state of the copper, nickel, and carbon steel markets over a several year period. These three were chosen because they comprise most of what we see on D&E projects. Now, many times, the risk of adverse fluctuation in the market can be mitigated through negotiated agreements with the mill or the scrap buyers, or for really long-term projects, tying the scrap credits into an index, such as London Metal Exchange, COMEX, or the American Metal Market. Additionally, it's a good strategy to have everything on your project ready to pull the trigger for when the scrap market is on the upswing, if you have the luxury of being able to do that. Now, I give you a lot of examples, but one particular project I was involved in, we took down an entire 600,000 barrel per day oil refinery. We performed an investment recovery assessment in advance, and then we followed the market until the composite value per ton was significant enough to allow for complete demolition, including asbestos abatement at zero cost to the owner. It can happen, not always, but it can happen. As owners and contractors, as I mentioned a while ago, there's a mutual benefit to submit the bids in a manner that apples can be compared to apples. Sometimes the apparent low bid is not the actual low bid. So if you look at this example, contractor number 2 appears at face value to be the low bidder, and they might actually be, but you need to know for sure. Now, if somebody made a mistake to get to that number, they're going to come back to you for change orders regardless, before they lose $5 million, regardless of what the contract says. So it's obvious that the two contractors did not look at the project the same. Contractor number 1 allowed for removing 15,000 tons of material, while contractor number 2 only allowed for removing 5,000 tons. Contractor number 1 has allowed for $3 million in hazmat abatement, while contractor number 2 only allowed $1 million. Contractor number 1 allowed for removal of 150,000 linear feet of underground piping, while contractor number 2 allowed for 400,000 linear feet. Now, there's a lot of other differences, but I think you get the gist. So who made a mistake and who got it right? Having a third and fourth bidder to fine-tune your bid bracket is one way to get a better handle on the best bid. Another way is to well-define your scope of work, spelling out not only what is included in the bid, but also what's not included. Also, don't forget to implement the right contracting mechanisms depending on the scope of work. Now, in any event, you need to balance the bids and ask the right questions to make sure the contractor has had a chance to revisit their numbers and ensure they can live with them rather than coming back to you for substantial change orders or even worse, walking away from the project. So remember, everything you see will come down at some time or the other. It might be 5 years, it might be 1,000 years, but it's going to come down. Gravity and corrosion makes that want to happen. The trick is to make it come down safely and economically without getting anybody hurt, damaging anything, or contaminating the environment. Any questions?
Thank you, Mike.
You're very welcome.
We have one question, and that's probably all we're going to have time for. When utilizing the equipment by either selling and or scrapping to minimize the cost of the demo, is the sale and the scrapping of the assets all included in one contract, or do you need separate contracts, one for selling, one for scrapping, and one for actual demo work? Concerned about the different terms and conditions related to each disposition. What do you say, Mike?
Well, it really all depends on the structure of the project and the timing of the project, how much time the folks have. Normally what happens is that the contractor is basically given the scope and saying everything within this scope of work is going to be included in your scope. So any credits that you get is going to be be credited back against the costs associated with that. So you can handle all that into one contract, but you also have to be concerned about product liability and how they do the sales, and make sure that you're covered contractually, so somebody doesn't come back to you as an owner on with a product liability concern because something blew up or had some kind of problem where somebody got hurt later on down the road. And if that didn't answer the question, let Jane know, and I'll make sure we come back with a more detailed answer.
Maybe we can squeeze this other one in. If you, how do you determine the gross tons, Mike?
The gross tons, if you've got the ferrous scrap, and the gross ton is basically, you figure out the pounds and you divide it by 2,240 pounds, which is the conversion factor from pounds to gross tons. And then you have net tons, which you divide it by 2,000 pounds.
Thank you. Thank you, Mike. And attendees, we hope you enjoyed the information shared in this webinar. For more information about the association, please visit our website at invrecovery.org. We encourage you to make plans today to attend our conference and trade show April 19th through the 22nd in Scottsdale, Arizona. We will have 3.5 days packed with education specific to IR professionals and have more than 50 exhibitors who are dedicated to helping you gain more value for your surplus and idle assets. We have several presentations expanding on this topic that you heard today, such as project management, safety, brownfield development, and handling of your hazardous waste. We look forward to your continued participation in the cross-industry learning opportunities and activities offered by the association. Thank you for your attendance and have a great day.
Thank you, everybody.